think we all have to remind ourselves that none of this has been done before. When you're reinventing everything, every component, every process, that spirit of innovation, you learn from that and then move on, iterate, and create something that ultimately changes everything.
We know that the world needs a really rapid shift to sustainable mobility, and we think that actually commercial vehicles play a really important part in that. We're going to see 40% more delivery vehicles in our cities within this decade. The demand and the appetite for fleets and governments and cities to bring electric vehicles into our cities is there, but the products aren't.
My name is Patrick Bion. I'm Chief of Product for the van programs here at Arrival. I'm responsible for all design, development and delivery of our van products. We know that the severity of the challenge for the health of the environment and air quality and the well-being of people living in cities. The current vehicles that many commercial fleets depend on have lots of limitations. As a diesel vehicle, trying to take that product and make it an electric vehicle and make it truly sustainable adds cost, adds complexity. Ultimately, that product will never have the same efficiency that a vehicle can that's designed from the ground up.
So all the products that we're designing at Arrival are part of a much bigger ecosystem. If we do this right, then they have the potential to change everything around us, particularly in the way that we use our cities. My name's Jeremy Offer. I'm Chief Design Officer for Arrival. One of the reasons why we've opted to design for more commercial sectors rather than private ownership means that that has the biggest chance of impact. We're surrounded by so much sort of visual noise, particularly in our city streets, that creating something that was calming, that felt iconic yet simple, was really at the heart of what we were trying to achieve. When we started the project and we started with our Alpha vehicle, we literally started off with this inherently simplistic box where we'd maximize the volume. And that was the key, is create as much cargo volume as possible. And what could be more space efficient than effectively a rectangular box on wheels? So the concept for the van was very much design it from the inside out to focus on the driver's experience. Research plays a very important role in the design of our vehicles. In the initial interactions with our drivers, there was a lot of interviews, understanding the pain points of our drivers, how they use the vehicle in their day-to-day lives, getting in and out of the vehicle. Literally every 5 minutes they're on and off that vehicle hundreds of times a day. Trying to make that experience as seamless and as intuitive as possible.
All of the repeat functions that a driver or a loader or any person using that vehicle goes through are really well considered, far more than there would be in an off-the-shelf, one-fits-all approach from another commercial vehicle. We really wanted to take all those learnings and make sure that we had a product architecture which we could scale across as many markets and fleets as possible. So the change we've made from the Alpha to the Beta architecture really enabled us to offer more wheelbase lengths, different battery capacities, different heights and widths, and different configurations. Whatever the requirements of a fleet, we've got a product which will meet that demand. There really is no reason for a company not to be choosing an electric vehicle now.
One of the main reasons for moving to the Beta design was the scalability of that as an architecture. As soon as we moved to Beta, there was a bit of a eureka moment where we realized that actually the curvature that we've got from, say, windscreen into roof, we could use that dimension and scale that up and down, and all of a sudden we had 2 or 3 different roof heights without actually breaking the design.
The biggest inputs into our design process on the van has been, how do we design a vehicle and a new assembly process together at the same time in a microfactory? So we want a product which can be built without welding, without painting, and without complex jigs that are going to be very specific to that one vehicle.
Reducing the complexity of every single component down to a point where the robot has simple, clean surfaces to attach to. That principle of reduction and simplicity sort of permeates everything that we do.
How are you, mate? Good to see you. How are things?
Yeah, all right. Not bad at all.
Good, man.
Good
Shall
to
we?
see it all coming together.
The key difference here really is it suddenly feels like it's designed around the driver.
Yeah.
It really does, like that ingress egress, that visibility.
Yeah.
You compare the two and that visibility is laterally and
Yeah.
downwards.
Yeah.
It's incredible.
We're not designing it as a vehicle as such, it is a piece of architecture
I
almost.
agree. And I think when people see the assembly process, they'll see the link between the
Yeah.
simplification of the exterior design.
Wow, that visibility is awesome, isn't
Incredible, isn't it? Absolutely incredible.
The achievements that have been made through this collaborative approach of engineering, design, assembly, build, has given us, I think, this amazing vehicle. And seeing it in the flesh is quite a moment to behold for the first time, for sure. The idea of form following the function of the vehicle gives us, I think, probably a very utilitarian vehicle. At the end of the day, that vehicle is a tool. It's to be used. It's not just to be looked at. It has to fulfill some very specific requirements. So creating this design, albeit beautiful, and simplifying all of the functions, all of the experiences, what does a driver need from a vehicle? All of these things distilled into what you're seeing now as our beta design means that we've created something really iconic.